Okay, welcome back to the land of the fractional equations. This set of notes is for 2 days. And the reason why is because in your list of topics, these are part of the same objective, and it made more sense to do it over 2 days. So these notes cover both Tuesday and Wednesday. I am making them due on Tuesday so that you have another day to just work on your topics, basically, so that you can ask questions still on Tuesday and on Wednesday about this. Okay, here we go. I'm going to try to explain these just a little faster than I did on the last one because it's using much of the same reasoning. Again, to get rid of fractions, you want to multiply by the reciprocal. If you have a proportion, you can multiply by the reciprocal or multiply by the LCD. It's a little easier, but here we go. We have a proportion here, if you recognize it, and if not, here goes. You don't always have to recognize it. -8 equals x plus 52. You can always use your equation questions, which is, what do I want to get rid of? Sometimes kids want to get rid of the 52 first, but you can't. You can't. Order of operations says do multiplication division first. So when you undo it, you almost have to backwards that. You have to go in reverse order. So we want to get rid of the -8 first. What's it doing? It's dividing. Okay, you want to get rid of a denominator? Multiply by it. Easiest way to get rid of it. -64 equals x plus 52. Just don't turn off your brain. Okay, what do I want to get rid of? The 52. What's it doing to the x? Adding. So how do I get rid of it? Subtraction. X is equal to 6, 1, 1, negative. Same sign, add, keep the sign. All right, next problem. Solve for W. Oh, wow, they act like they give you decimals and it's a little bit harder. It's the same thing, okay? Same process. Okay, here we go. What do I want to do? I want to solve for W. Yes, solve for W means get W by itself. What do I want to get rid of? I want to get rid of the 5, but 5 is multiplying. Okay, right here, correct? And you think like, oh, well, you said to undo it, but we can't do it. It's so close to the W right here. Okay, we have to get rid of the stuff that's being added and subtracted first here. Okay, in this case, this is a positive. That negative belongs to the 5. Always read from left to right. Some of you guys are still struggling with that. Okay, that is a -5. That is a positive 16.7. How do I get rid of it? Negative 16.7. We subtract 16.7 from both sides. Cancels. Bring down the negative. Do not forget that negative. That's usually the number one mistake kids make. Okay, and yes, look at the bottom number is bigger than the top. You cannot subtract them. You're going to need to come over here and do negative 16.7 plus 4.2, which means you subtract, because they're opposite signs, 5.12. Okay, negative 12.5. Don't forget, if this is a larger number, they're different signs. You subtract, keep the sign of the larger number. Negative 12.5, divide by -5 to get rid of the -5. W equals, and then you go negative 12.5. You don't actually need to put the negative when we're dividing. That's silly. Don't do that. Divided by 5. Again, you can use your calculator here. I don't care. 5 goes into 12, 2 times 10, bring down the 2, bring down the 5, 2.5. Okay, and that is the answer, 2.5. Moving on. All right, this is solving a linear equation with several occurrences of variables on both sides and 2 distributions. This is actually a pretty complicated problem, and there were other easier problems that came before, but most of you had those accomplished already. So we are going to go ahead, I'm going to go ahead and rewrite this problem here. Okay, there are a few of you that are still screwing up with distribution, so it's a good reminder, but the problems leading up to this will probably be good for you. Okay, so distribute. It means you distribute to each one of these. Okay, and we are going to write that out. So here we go. I'm going to go negative 3 times 8v minus, that's this minus, okay? Negative 3, that's this negative 3. Maybe I should even write it. See, if this is negative 3, that is this negative 3. Yeah? And this is the minus in the problem. Don't get confused with what is what. That is also a big confusion for a lot of people. Plus 6 equals negative 3 times v plus, down the sign, negative 3 times 3. For those of you more advanced who already know how to distribute signs and stuff, don't worry about it. Just jump to this next step. This is what you would have done. You would have jumped to negative 24v plus 3 plus 6 equals negative 3v minus 9. So if you can jump to this point, you are perfectly welcome to do so. I'm not going to hold you back. 24v plus 9, combining like terms, equals negative 3v minus 9. Add, you have a choice here. Okay. And it doesn't really matter which way you go, but you need to get the v's, you need to get the variables on one side, okay, and the numbers on the other, okay? So we need to move things around. So I'm gonna go ahead and add 3v only because I like putting the v on the left-hand side. It's not gonna get rid of the negative, and that's not gonna make a lot of you happy. So it just depends on you, okay? I'm gonna add 3v here because I like reading left from right, and I like it to say v on the left-hand side. Okay, plus 9 equals negative 9. Now I need to get the numbers over there. So subtract 9 from both sides, and I'm going to get negative 18 equals negative 21v. So v, I'm going to go over here because I ran out of room. You can continue down on yours. Negative 21v equals negative 18. Divide by negative 21 on both sides. And a negative divided by a negative is a positive, and both of these are divisible by 3. 3 goes into 18 6 times. 3 goes into 21 7 times. Again, it's assumed you know how to reduce fractions at this point. All right, moving on. Next one. Oh my gosh, this looks crazy, right? Okay, we are solving. Notice there's two y's. Several occurrences of the variable. See, occurs twice. Fractional forms with monomial numerators. In other words, we just got fractions and variables. So you know what? It's a problem. Let's do the problem. Okay, when you have fractions, you want to get rid of them. Multiply by the LCD. And in this case, what's the LCD between 4 and 10? Well, 4 doesn't go into 10. So let's multiply 10 by 2. Okay, well, the next multiple of 10 is 20. Does 4 go into 20? Yeah. So, yay, 20 is the LCD. All right, so here we go. Y over 4 plus y over 10 equals 7 over 4. We are going to multiply everything by 20. So we're going to go 20 times y over 4 plus 20 times y over 10 equals 7/4 times 20. A little dangerous what I just did by putting it on the right-hand side. If you do that, I highly recommend you put it on the left. Put it in parentheses. It's not dangerous in this problem because the LCD is 20, but sometimes when there's subtraction, it can be a little dangerous. Lose signage. All right, so here we go. 20y multiply across. Again, I'm showing extra steps for those people that are struggling with fractions. To multiply fractions, you simply multiply across. Okay, you need to remember that. 20 over 1, 7 times 20 is 140 divided by 4. Now simplify. Okay, simplify. We're going to go 20 divided by 4 is 5y plus 20 divided by 10, 2y equals 4 goes into 14, 4 goes into 14 2 times, and then that leaves 4, 28. All right, these are like terms. We can add them. 7y equals 28. And then if you like don't lose your brain and you like are like, ooh, 7 times the number is 28, you could immediately jump to y equals 4. If you're not really thinking and you're like, ooh, I just need to show my work, just show you. And then you'll be like, oh yeah, it's 4. All right, moving on. Oh man, more fractions. It's okay, we're good. Again, multiply by the LCD. What's different between this one, this problem, and the last one? These little negatives. They are there to screw you over, and you need to be very aware of them. Okay, so here we go. 7 fourths equals negative 7 thirds x minus 3 halves. Okay, what's the least common denominator between these to get rid of it? Well, start with the biggest number, 4. Does 3 go into 4? Nope. Double it. 8. Does 3 go into 8? Nope. Triple it. 12. Does 3 go into 12? Mm-hmm. So the LCD is 12. Okay, we need to multiply this one by 3 to get to 12. 3 over 3 is just a fancy form of 1. This one by 4. 4 over 4, fancy form of 1. And this one by 6. And then we'll have everything over 12. Okay. I still have kids that are getting confused between when you multiply and when you need a common denominator. We are multiplying by the common denominator to get rid of the fractions. It is a cool little trick. Okay. That's why we are doing this. So we get, why did I do that? Y'all, I did this a whole different way. I don't want to do this. Okay. I could do this. This way I was just making them all fractions. I don't want to do this. I'm sorry, y'all. I kind of lost my way. Here, I'm going to multiply by 12. I don't know what I was thinking. I was just thinking, hey, I'm going to put them all over a common denominator. Silly me. Don't do that. 12. Okay, equals times 12 and times 12. All right, there we go. Sorry about that. Okay, here we go. 4, 12 over 1, 4 goes into 12. Maybe I'll pick a different color. 4 goes into 12 3 times. 3 times 7, 21 equals. Okay, 3 goes into 12 4 times. 7 times 4 is negative 28x. Minus 2 goes into 12. So this is so much better than what I was doing. Is 18. What I was doing was not incorrect. It was basically just working it like a fraction problem. But who wants to do that? All right, so we want to solve for x, so we got to get rid of the 18 first. Don't get rid of the one that's right there next to that x first, the one that's multiplying. Get rid of the stuff that's being added on first. Bring down the 28x. Add these two together, they're the same sign. Add, keep the sign. Divide by negative 28, and that is your answer. Positive divided by negative, bring it to the top. Don't leave the negative on the bottom. Bad form. There we go. Next problem. Okay, are you sick of fractions now? I am. Okay, but that's okay. Multiply by the LCD. Okay, LCD for this one is between 5 and 2. This one's over 1, 10. Okay, so we're going to go negative 4/5 V. I'm just going to multiply it by 10 right away. Okay, plus 6/5 times 10 equals negative 3V times 10 minus 5/2. Ooh, I'm almost running out of space. Times 10. Okay, there we go. All right, canceling common factors. You can always multiply across though. 40 divided by 5 is 8, right? 60, 6 times 10, 60 divided by 5 is 12. You can always multiply across and then divide. I know a lot of you like that better. I want you to learn how to do this, where you go, wait, 5 and 10 have a common factor. 5 goes into 10, 2, 5 goes into 5, 1. 1 is on the denominator, we're good. Now you're going to go negative 8V plus, on this side, 5 goes into 10 2 times. 6 times 2 is 12 equals negative 30v multiplying across minus, don't try to make that into a fraction. There's no reason to put that over 1. Don't do that. I've seen a lot of kids do that recently, and I don't know why. Okay, and then here, 2 goes into 10, 5 times 5 is 25. All right, now we just have a problem with variables on both sides. Okay, again, I told you I am prone to moving left to right. A lot of times kids like moving the higher number over, which is kind of like what's happening here, because it keeps it positive. You get 22v plus 12 equals negative 25. Subtract 12 from both sides because we got to get rid of it before we divide, remember. Negative 37 divided by 22. V is equal to negative 37 over 22. No slanted fractions, please. Leave them like this, top and bottom. We are no longer doing this. This is no longer allowed in algebra. Okay? No, no, no. Don't do it. Okay, moving on. Here we go. Next problem. Wow, you think this looks like scary, but as long as you keep yourself organized, you're gonna be fine. Okay, again, LCD. What is the LCD? 1 is over 1. The LCD between 5 and 4 is 20. So here we go. In this case, I am going to show the parentheses because it makes it much easier. Okay, this is probably the hardest problem you're going to get in this whole thing. If you can do this, bravo to you. Okay, so we're going to multiply 20 times 9x minus 3 over, actually, I'm going to separate this because I can, over 5 minus 20 times 5x plus 6 over 4. Okay, and if you're confused about why I did that, there's a 1 under there. I'll leave it to the next step, but it's perfectly fine to do it. Okay, and negative 1 times 20. There we go. Now we're going to do the multiplication. Switch colors, because why not? Okay, but before we're going to do the multiplication, okay, let's take a look. These are two fractions. These are, we can cancel common factor. 5 goes into 20, 5 goes into 5 once, 5 goes into 24 times. We can now rewrite this as 4 times 9x minus 3. Look, we got rid of the denominator. 4 goes into 25 times. 5 times 5x plus 6 equals negative 20. That was the whole point. Yay! We did it. We got rid of the dang denominators. All right, multiply across 36x minus 12. Don't forget your negative on this one. Negative 25x minus 30. 5 times 6 is 30. Negative times positive is negative. Be careful, people. Common terms, like terms, 36x minus 25x. 36x minus 25x is 11. 11x, and then we got negative 12 and negative 30, which is minus 42, equals negative 20. We want to get x by itself. Get rid of the 42 first. Wow, this computer is like really hot on my leg. Okay, 11x equals 42 minus 20. Remember, they're different signs. So 42 minus 20 is 22, yeah? Oh my God, we got a nice pretty answer this time. 11x equals 22. Divide by 11, and voila, you get 2. You guys know the word voila? It is French, and it means there it is. All right. Yay. All right. Do you see why I'm giving you 2 days to get through these 9 topics? All right. Next one, solving equations with a 0, 1, or infinitely many solutions. When you have a line, okay, and we are graphing 2 lines. Do I want to explain this right now? I don't think so. What? I'm going to backtrack. Back it up. Back it up. Okay, I just want you to know this for right now. Okay, if the variable disappears when you're solving, and A, you get a true statement, it means any number will work. So all real numbers is the solution to that. That is all real numbers. Basically, that means you can plug anything in and you will get a true statement. What it really means is that both sides are the same. Okay, if you get a false statement, it means no solution. And I'll explain what this means as we get through it. Okay, and you also will get one answer. The third possibility is an answer. Okay, one solution. And that would look like this. X equals Y equals. And there would be some value right here. Okay, let's look at this. I'm going to leave that there. So, well, we'll see. We might need to erase that. And so you copy it. You can pause the video and copy that down because I'm about ready to get rid of it. Okay, it's really important though. So you need to have that in your notes. Again, the cool thing about me recording notes is that you can go at your own speed. You can stop. You can actually try to guess the answer before I do it, see how good you are, and then speed it up. You can work it to your advantage. All right, so for each equation, choose the statement that describes its solution. If applicable, give the solution. That means if it has a solution. All right, so here we go. We got 4 times v minus 1 equals 2 times 2v minus 3. Okay, let's see if this variable is going to disappear, and I'll show you what I mean. Distribute minus 4 minus 1 equals distribute 4v minus 6. 4v minus 5 equals 4v minus 6. Watch. When I want to get rid of 4v, I end up getting negative 5 equals negative 6. That is not true. What that means is that when you plug in v, there is never going to be a number that you could plug in and get a true statement. So the answer here is no solution. Okay, so here we go. It's no solution. Okay, let's take a look at the second one. Again, I'm going to have to erase. Here we go. 4 times x plus 1 plus x, my bad. Here we go. Plus x equals 3 times x minus 2 plus 2. Here we go. Distribute 4x plus 4 plus x equals 3x minus 6 plus 2. Distribute. Yeah? Combine like terms. 5x plus 4 equals 3x. Combine like terms. Minus 4. Subtract 4. Actually, you know what? Since I've been, you can do that. That wasn't wrong. Since I've been doing this, I'm going to go ahead and do that again. This time, look, we're subtracting, and look, the variable didn't disappear. But I don't like where I wrote that. Let me see. No, that was fine. Hang on. I'm good. 2x plus 4 equals negative 4. Do not forget to bring down the negative. See that? Carry it along. Bring down the things. Okay. And now we're going to subtract 4. Draw the line. Always draw that line. 2x equals negative 8. X is equal to negative 8 divided by 2. Right? Divide both sides by 2. Actually, you know what? I'll just write the answer. Okay. X is equal to negative 4. And that is one solution. X equals negative 4. You would just plug it in. Okay. If you had this last situation, there is a situation that you could have where, and I'm just going to give you a really simple problem. They're purposely making these more complex. One, to get you good at distributive property. Two, to help you have practice adding real numbers. But I'm going to give you a simple one. Let's do 3x minus 8 equals 2x plus x minus 8. All right, add like terms. You'll get 3x minus 8. Now, some of you would be brilliant and be like, oh, wow, look, they're the same on both sides. But let's say you're not. Let's say you're like just hanging out. You're just doing your automatic thing. Look at the variable disappeared. It went away. It was like poof, it's gone. And what are you left with? -8 equals -8. But this is true. What that means is that for any number, this would work. So that is the solution that's going to give you that one. All real numbers are solutions. Last problem. All right. This is a proportion. I love proportions because this is when you can cross multiply. I absolutely hate the words cross multiply because kids think you're always cross multiplying. When you're canceling common factors, they're like, you cross multiply. No. When you're getting common denominators, you cross multiply. Nope, you don't. This is the only time. When you have a proportion, you cross multiply. Okay, but really you're just multiplying by the LCD. I'll show you what I mean. All right, so if you remember cross multiply, then you could go 5 times 12 equals 8 times u plus 3, and then solve it. 60 equals 8u plus 24, subtract 24. 8u is equal to 36, positive because the 60 is positive. Divide by 8. So u equals 36/8, but you need to reduce it because both of these are divisible by 4. Actually, yeah, divisible by 4. 4 goes into 36/9, and 4 goes into 8/2. And that's your answer. All right. I want to show you that this is the exact same thing as we've been doing. In that, look, we were like, you know what? I want a different color. So I already used red. Let me get a different color, blue. All right. So if you had 5/8 equals u plus 3 over 12, what's the common denominator between 8 and 12? Well, 8 doesn't go into 12, so double 12, 24. Does 8 go into 24? Cha-ching, yes. So LCD is 24. Check it out. We can multiply both sides by 24. We're just going to put that like that. Okay, and let's put that in blue. 5/8 equals u plus 3 over 12. Okay, remember this is over 1. Okay, over 1. And we can cancel common factors again. 8 goes into 24 3 times. 3 times 5 is 15. I don't like that yellow. 12 goes into 24 2 times. And you will get, let me rewrite this in blue, 15 equals 2 times u plus 3. Remember, multiplication is commutative. I could also distribute from this direction, but I switched it around because I like doing left to right distribution. 15 equals 2u plus 6. Subtract 6, and you get 9 equals 2u. U is equal to 9 halves once you divide by 2. By the way, if you are advanced enough to not show work, you are welcome to do it. If you have trouble organizing signs and you lose things like negatives, show your work. If you are having trouble with things like keeping track of negatives, let me go back on a problem. Last recommendation. Where's the one where they really try to get you? Okay, here's one. What I highly recommend you do is you can go back and you can actually, keep it yellow. Well, no, I'll do it green. You can highlight this so that you don't lose it. Although this is supposed to be a highlighter, and it is totally like, that is horrible. That is terrible. It's not a highlighter. That was like the worst highlighter on planet Earth. All right, anyway, the whole point is that you could, okay, idea is that you could do some kind of visual to a visual cue to keep your negatives in so you don't lose them. So you realize, oh, okay, wait a minute. I had this green negative. Here's my green negative again. Green negative, green negative. Yeah? You see how this makes it go away? You see how that makes it really obvious? And you're like, okay. So if you're having trouble with that, that's a tip. All right? And that marks the end of this video.